Hello and welcome, my name is Brent and this is the 11th devlog for Blue Sky Aces, a retro World War I flight simulator inspired by the games I played when I was younger. Right, we're going to get straight into the good stuff today. The big new feature worked on over the last few weeks was the Infantry assault system, where we can simulate hundreds of infantry soldiers charging across a battlefield and assaulting an enemy trench network. From the point of view of the player, the system opens up two new mission types. Either a defensive mission where the player's goal is to prevent the infantry achieving their objective via various means, or in a supportive role where the goal is to protect the infantry and eliminate any potential threats to them. There are many different ways of achieving this type of effect in games. However, as this is a flight simulator and not an RTS or some other type of game, this isn't a main feature of the game, so I need to be careful that it doesn't take up too much of the processing time. I've decided on a budget for this feature of somewhere between 5 and 10%, and I want to be able to support up to 1,000 soldiers, although in practice I don't intend to cap that limit. To achieve these performance goals, I've gone for a centralized management approach. The reason for this is I can save valuable processing time by not having to have individual soldiers figuring out their own way of navigating the battlefield and avoiding each other. For even more performance games, I've pre-calculated a lot of the information that the system needs to move the soldiers, which means that their movement behaves a lot like an animation. So here's how it works. The system consists of a simple bounding box, whereby the goal is for the infantry to navigate from the green starting line to the red finishing line. At design time, I simply click a button which pre-calculates all of the routes that the infantry will take. The routes have a bit of random variation left and right, but basically they form assault lanes that infantry follow. This removes the need to do collision detection between lanes. Each lane consists of a number of segments, whereby nodes between segments are defined by a point in three-dimensional space. The infantry move in straight lines within a segment, but can change direction at the nodes between segments. Each segment consists of a number of height intervals, where I only store the height of the terrain at regular points along the segment. To move a soldier along a lane, I simply multiply the current segment vector by the soldier's speed, then calculate the height using the height intervals, interpolating the values between the height before and after the destination position. When the soldier reaches the end of a segment, he moves to the next segment and repeats. With a system, I don't need to worry about raycasting to find the ground, and the only soldier versus soldier collision detection I need to worry about is with the soldier in front of the one that's currently being moved, which is as simple as comparing the distance of both soldiers along the assault lane. To finish off the system, I define an attack zone around the enemy trench. Soldiers within the zone will look for approaching infantry that are within an attack range every 4 to 5 seconds, and then do damage to one of them. In turn, the attacking infantry do the same. This rather crude approach to combat looks believable enough from up in the air, and typically means that the side with greater numbers will generally win. The only exception to this combat system is the machine gunners, which have a more traditional find target, aim, shoot bullets, which then damage attacking infantry. Hopefully that provides a bit of insight into how it works, and more importantly, makes sense. If anyone would like more information around specifics, then just drop a comment down below and I'll be happy to provide more information. The other task worked on during this period was the replacement of a couple of aircraft models and the addition of a new one, the Fokker DVII. These models are all created by someone else who's offered to help out with the 3D modelling tasks. Over the next couple of months we'll replace the other models that you can currently fly in the demo, as well as add a whole lot of new aircraft. The first model updated was the Airco DH2, which is looking really good. Updating the models turned out to be a fairly straightforward process. All I needed to do was ensure that the various aircraft parts were named the same, and then overwrite the existing files. From there I just needed to check that items like hitboxes, wheel sizes, propellers and so on all lined up with the updated model. That was closely followed by the Fokker Eindecker, which is a great texture that adds a nice bit of extra detail. Once again, this was a similar process that took around 2 hours to complete. The Fokker DVII was the last one introduced, but because this was a new aircraft there was a bit of extra work to do. The process consists of the following steps. First, I do what can best be described as rigging the model. This is where I add a component that makes it simple to animate the control surfaces and propeller. Next, I create a player version of the aircraft, which usually begins by cloning an existing player aircraft and then swapping out the aircraft model. There's usually a bunch of stuff to line up with a new model, such as hitboxes, wheel and gun positions, as well as defining the aircraft's performance characteristics. Now I define what can best be described as a breakable copy of the aircraft. This is a model that has physics joints added between the aircraft parts. These joints break under impact forces, causing parts of the aircraft to detach on a collision. The way it works is that the player aircraft gets swapped out for the breakable copy when a collision is detected. The last aircraft prefab required is the preview, which is only used on the menu when selecting your aircraft. There are two other aircraft prefab variants that we can create, one being the AI piloted one and the other being a static ground target, but these aren't necessary to test fly the aircraft. The last step is to add the aircraft to the player aircraft collection, provide a preview image and translated strings for the aircraft specifications. At this point, the aircraft can be selected from the menu and be used to fly a mission. Generally at this point there's a bit of time spent playtesting and fine-tuning the aircraft. If you're interested in seeing which aircraft are currently being worked on, or any other feature, then check out the Discord link in the description, where we post regular updates of what's currently being worked on. Over the next 2 weeks I'm going to continue to add new content, including new missions, aircraft and game mechanics. I really want to focus on getting a solid amount of content finished this month, before I look at any of the really awesome suggestions I've received through the various feedback channels. Well, that's it for this time. If you enjoyed this, then please hit the like button and click subscribe to continue to follow my progress. If you'd like to know more, then check out the link in the description to the game's Steam page and give the demo a try. Don't forget to wishlist it so you'll be notified when the game is released.